Hello, welcome back. Today let's try to solve another Leetcode problem 1283. Find the smallest divisor given a threshold. Now let's read the question first before I solve the problem. Given an array of integers, nums 1, 2, 5, and 9, and we also have a threshold. So we just need to find, so here, find the smallest divisor such that the result mentioned above is less than or equal to the threshold. So what is above? We will choose a positive integer divisor. So for here, we're going to find a positive integer divisor. And then divide all the array by it and sum the divisor's result. We should take care the sum of them should always be rounded to the nearest integer greater than or equal to the element. Now let me explain this example. So for here, we can get a sum of 17. So this means if the divisor is 1, of course it is 17. We need to plus these numbers. So if the divisor is 4, so here will be 1 plus 1 plus 2 plus 3. So it is 7. And if the divisor is 5, now 1 plus 1 plus 1 plus 2, it is 5. So it is our result. Because our result is the smallest divisor, such that the result mentioned above is less than or equal to threshold. So this divisor, for this divisor 5, it meets the conditions. This is the smallest. Even here, the divisor is 1. It's not possible because our sum is 17. It is not less than or equal to the threshold 6, because here it is 5, it is less than 6. Maybe you think, what about 6? Can I take another number 6? If we take a 6, it is 1 plus 1 plus 1 plus if we take another, so here is the divisor 5, we can get a sum of 7, and if we take a 6, let's try the 6, it will be 1 plus 1 plus 1 plus 2, it is still 5. And if the divisor is 5, the sum will be 5, less than the threshold. If the divisor is 6, but we need to find the smallest number, this 5, because the 6 is not the smallest number. If we choose 6 or 7, even it is okay, but this is not the smallest number. So this means our check is right. If we prepare a bigger number like 6 or 7, it is okay. What about we prepare a smaller number like 4? If we prepare a smaller number 4, it means the sum of them will be 7 is more than the threshold. It means it is not right. So this means our final result should be 5. For this problem, normally we're gonna try to use a binary search for a value to solve the problem. So this is a template. So this template, I will call it binary search a value. So this value means our result. We just need to use a binary search to guess the value. It may be smaller, as I explained. If we guess the number maybe 7 or 6, it is too big. Even it is true, but it is too big, we're gonna guess a smaller number. Maybe we guess a number 4, but we got a sum of them 7. It is the threshold is too big. It means it is not true. So we're gonna guess another number, maybe 5. Now 5 is true because 5 is less than and equal to 6, and we cannot find a smaller number than 5. So this means we're gonna return 5. Now let me write the template for the binary search and search for value. So basically, I'm going to write a check function. Here, I have a threshold. So inside, I'm not going to use the threshold, just use m. Because inside of the binary search, I'm going to use this m. It means the made numbers I need to guess. And here, I just write a parse. Later on, I will finish the parse function. So for this, finish the parse. So basically, for this check function, it is these areas. We just need to understand what's the meaning of this description and then finish the check function. Now we can write the binary search. And for binary search, we need L pointer and R pointer, and I also need a result. For the L pointer, we need to check the smallest value. Let's check the smallest value because we are going to choose a positive integer in this method. So this means our smallest value should be 1. 1 is the smallest positive integer. And we can also check it from here. There is a divisor, it is 1. 1 is the smallest. So what is the biggest? The biggest number we can check from here. The threshold is more than and equal to the nums.less. For example, this one, the less of nums is 4. So if the threshold is 4, so what is the maximum number we can have? So we can have a 9. It means the max of nums. We can even have a bigger number, 10 or 11. But it's not necessary. Why not have a smaller number, 9? Because 9 is the max possible numbers. If we try a bigger number for binary search, of course it works. For example, we can use 10 to the power of 9 or 12. It works, but it's not necessary. We can just use the max of nums. And here result, I will keep the smallest number as 1. Now I'm going to write the template for binary search. For such problems, I will always use L less than or equal to R, and then I'm going to have the made number. It should be L plus R minus L divided by 2. Now I'm going to check. If I check this number M, so this means I'm going to check a number if this number is not 5. If it is a 6, as I explained earlier, so if it is a 6, it is okay, but it is too big. But for my result, I will have this M, but for the binary search, I will use R equal to M minus 1 because I'm going to get a smaller number, because I'm going to return the smallest possible numbers. So here is what we're going to return, for the smallest. This is why we needed to use R equal to M minus 1, because this R M minus 1 or else L equal to M plus 1. So these two lines is always dependent on the descriptions of the problem. If this is the smallest, of course here we're going to use R equal to M minus 1 to get a smaller number. From here we can always get a smaller number. And here this means if this number is too small and it is false, it's not possible, we're going to get a bigger number. So here is why we use L equal to M plus 1. Now I just need to return the result. But before return the result, I just needed to finish the check function. So for the check function, I just needed to check how many numbers. I'm going to define a variable count is used to count how many numbers, like here, we call it as 5. Now I'm going to loop through the nums for any nums. So the count should plus this n, because here we always need to round it to the nearest integer greater than or equal to that element. This means we're going to use a cell in Python, and cell should be inside n divided by this m. So m is our guest number, our guest. If our guest is 5, so it will be divided by 5. Now we are going to check how many count do we have. Just need to return the count less than and equal to threshold. Here you may guess why count is less than or equal, why it is more than or equal. Because this is why, because here we just need to check our count. For example, this count is 5, it means it is true. Our threshold is 6. So this is also inside the description. We just need to find some numbers less than or equal to the threshold, because here said less than or equal to threshold. So this is why we're going to use our guess if it is less than or equal to threshold. Now let me run it to check if it really works. Now let me submit it to check if it can pass all the testing cases. And by the way, the time complexity is m times log n. So n is in the log n is in the binary search areas. M is the length of the nums array. As you can see, it's pretty fast. Thank you for watching. See you next time.